In the last presentation, we talked about solving radical equations by squaring both sides. In this presentation, we're going to talk about the exact opposite, which is the square root property. So our procedure in order to solve equations using the square root property, the first thing we want to do is isolate the squared thing. From there, we can take the square root of both sides, including plus and minus. From there, we want to simplify the root, and we're going to finish solving for the variable. To demonstrate a very basic example, let's look at x squared equals 9. So what squared equals 9? Well, most of you will probably say 3. But if you square -3 as well, you will also get 9. And so we have plus and minus 3. So what did I do in order to get from the top step to the bottom step? I take the square root of both sides, and I include the plus and minus. Alright, so let's step it up a little bit and look at some examples that are a little bit more complicated. Alright, for example A, we have x minus 4 equals 9. My squared thing is isolated, so I can take the square root of both sides. On the left, my square root and my square cancel, leaving me with just the inside thing, which is x minus 4. On the right, I want to take the square root of 9, which is 3. And again, I want to include plus and minus. Now we want to finish solving. To get x by itself, I'm going to add 4 to both sides. And you do need to be careful when you do this. This is not plus and minus 7. This is 4 plus and minus 3. Now I want to separate this. So what we have here is we have x equals 4 plus 3, or x equals 4 minus 3. We can simplify each one of these and we get x equals 7, or x equals 1. Let's try another example, a little bit more challenging. Let's look at example B. My squared thing is isolated, so I can go ahead and take the square root of both sides. On the left, my square root and my square cancel, leaving me with 2x minus 3. On the right, we get the square root of 25 is 5, and I'm going to include my plus and minus. Alright, we want to finish solving, so I'm going to add 3 to both sides. We get 2x equals 3 plus or minus 5, and then I can divide by 2. So we get x equals 3 plus or minus 5 over 2, and now I want to separate this out. So we get 3 plus 5 over 2, and we get 3 minus 5 over 2. If I simplify the first one, I get 3 plus 5 is 8 over 2, which is equal to 4. In the bottom one, I get 3 minus 5 is -2 over 2, or -1. And there are my two solutions. Now, technically on these ones, we could have multiplied out and then used factoring in order to solve because we came up with nice answers. So why would we want to bother with this? Well, this comes up mostly when we talk about things that do not simplify, things that don't have the square root, things that are not factorable. So let's go ahead and look at some examples of that. All right, if we start with example C, we have x minus 5 squared equals 20. I'm going to go ahead and take the square root of both sides. On the left, my square root and my square cancel, leaving me with x minus 5. On the right, I'm just going to write square root of 20 for now. And I'm going to include my plus and minus. Now 20 is not a perfect square, but I can still simplify this. And so we want to go ahead and factor 20. Does it contain any squares? Yes, it does. I can rewrite this as 4 times 5. 4 is a square. And so now if I take the square root of each one of these, I get x minus 5 equals plus and minus, the square root of 4 is 2, and my 5 stays inside the square root. All right, we want to finish solving, so I'm going to add 5 to both sides. And for my final answer, I get x equals 5 plus or minus 2 square root of 5. Now, when you're working on your homework, unfortunately, they might not have the plus and minus symbol. And so when you write your answer, you may need to write it out as 5 plus 2 square root of 5, comma, 5 minus 2 square root of 5. All right, let's look at one final example. We have D. D, we have 3x minus 4 squared equals 12. So if we start by taking our square root, on the left, my square root and my square cancel, leaving me with 3x minus 4 equals the square root of 12. Include the plus and minus. Does square root of 12 simplify? Well, though it's not a perfect square, I can go ahead and factor this. This is equal to 4 times 3, and 4 is a perfect square. So when I take the square root, I get 3x minus 4 equals plus or minus, the square root of 4 is 2, and we leave 3 inside the square root. Okay, from here we go ahead and finish solving, so I'm going to add 4 to both sides. We get 3x equals 4 plus or minus 2 square root of 3. And then I can divide by 3. And we get x equals 4 plus or minus 2 square root of 3 over 3. This does not simplify any further. Please note that we cannot add the 4 and the 2. The 2 is with the square root of 3. It can only combine with other square root of 3 terms. It cannot combine with non-square root of 3 terms. And so this is our final answer. For our homework, we're going to type in 4 plus 2 square root of 3 over 3, comma, 4 minus 2 square root of 3 over 3. And that takes care of the square root property.